a little horse trading and a liquidation of a few assets, I finally hit the big time. One of the first scopes I had was a Celestron 8-inch SCT. I bought a Hyperstar from Starzona and took advantage of the FastStar system, which involved removing the secondary mirror and replacing it with the Hyperstar, and along with my attic CCD camera mounted to it. In this configuration, I basically got f2.2. However, even at fast imaging, the SCT with the Hyperstar had its own problems to speak of. First thing was mirror flop. Another was having to collimate if I switched back to visual use or from visual back to Hyperstar. Basically, every time I moved to the secondary, I had to recollimate. And of course, the biggest issue was guiding an SCT using a guide scope. I mean, I guess I should point out though that I was using an AVX mount at the time. Not exactly top of its class. Of course, I moved on to other scopes and settled on refractors. Until now. Celestron had already released the 11-inch RASA. Wait, RASA, or maybe not important. Well, maybe important. What exactly is a RASA? Well, RASA stands for Rowe Ackerman Schmidt Astrograph, RINC, which was designed by who else but David Rowe and Mark Ackerman. You see, prior to the introduction of the RASA, Celestron had developed a system on their SCT line called FastStar back in the 90s. Basically, as I said earlier, you remove the secondary mirror and you install their FastStar system with the Celestron Pixel 255 camera. Later down the road, Celestron gave up the FastStar system even though they continued to manufacture the SCT, with the ability to remove the secondary on some of the models. In the meantime, Starzona had developed a Hyperstar to be able to use on the SCTs. So along with some conversion kits, camera adapters, and other odds and ends, they basically took over. The only problem here is that the SCT wasn't designed to be a standalone astrograph. It could be used visually, and you could even mount a DSLR camera on the back or even a CCD. But if you're shooting from the back, you were shooting at a long focal length and very slow speeds. Changing to the FastStar or Hyperstar was easy enough, but when done, you had to tear it down, you risked getting dirt into the OTA, scratching your corrector plate while removing the secondary, and of course you had to deal with collimation issues if you banged it against the wall. Then, figuring to that, the dreaded mirror flop. Of course, if it was permanently mounted and never changed to visual, you were awesome sauce. Yes! So fast forward a little bit. So down the road, the mirror flop issue was addressed and better optics were developed in the Edge HD line. In addition to much better mirror and plates, they were also given mirror locks and features to cool down the scope. This was certainly an improvement over the standard SCT, but again, it wasn't really a dedicated astrograph. So apparently there was a need for something better. Hence, Rowe and Ackerman got together, and finally in 2014, the 11-inch RASA was introduced, the first truly dedicated astrograph for Celestron. Everyone shouted from the rooftops, and the heavenly thanks were given, and the seas parted, and, oh wait, it cost like $3,600. Back to the SCT, I guess. What made the RASA different to the SCT with the Hyperstar or the FastStar system was that it was dedicated and designed for the specific purpose of being a true astrograph. The optical path was designed to bring the prime focus focal plane to the front on purpose, not as an afterthought like they did with the SCTs with either FastStar or Hyperstar. In addition, the mirrors were changed and the focus system was revamped. Mirror locks were added and the 12-volt maglev fan was installed to cool down the primary mirror. For the cash-strapped populace, the 11 was a little out of reach, so most stuck with their SCTs and the Hyperstar. But wait, they released an 8-inch? Holy shit! Yep, 8 big ol' inches, or 8 little ol' inches. That's what she said. Yeah, anyway, while it hosts the same features as its bigger brothers, the 8 is a little more selective. At 400 millimeters of focal length, a little over 24 inches long, and weighing in at 17 pounds, this is the perfect scope for a fast drive-by when you don't have 8 hours to spend all night imaging. Using a DSLR is out of the question on the 8, and in some cases, a full-size filter wheel is also down and out when shooting mono. Typical cameras you'd use on this model would be a smaller CCD or a CMOS with an APS-C sensor and some mirrorless cameras. In fact, Celestron recommends that you don't use anything 4 inches and larger on the 8-inch, as anything bigger will interfere in the optical path, so you might be limited here. This scope would be perfect for anyone using a one-shot color CCD or a CMOS, and Celestron also makes available adapters for mirrorless cameras such as Canon and Sony. And matter of fact, you should also probably consider something like the Attic Infinity, or anything that you're shooting video. In fact, keeping one-shot color cameras in mind, Celestron has a dedicated light pollution filter that can be fitted into the space where the standard glass filter resides. Now, while designed and sized for those with one-shot color cameras, it doesn't mean you cannot use a mono. In fact, we found a way. Arizona has a perfectly sized filter drawer system that can be used on the 8-inch RASA. It is a little tight and some further engineering needs to occur at Arizona, but it is doable. What makes this almost damn near perfect is that the 8-inch RASA requires 25 millimeters of back focus. The ZWO ASI 1600 and the 183 both have 6.5 millimeters of back focus. Then add the drawer with a 1 millimeter adapter, brings it to a perfect 25 millimeters. But it is tight. I mean tight. What would benefit here is a tiny knob on the top of the filter drawer. I've improvised a little piece of tape here, but you could also consider adhering a small cap head or anything to allow your fingertips to grip and pull it out. Now, I've sent some pictures to Arizona and I recommended that they find a way to add something here in order to make this easier. So until further notice, this is about all you can be able to do if you go mono. So it all sounds too good to be true, right? Right. Well, there's an absolute heavenly breakthrough for astrographs and makes it affordable to the common imager who doesn't own his third house in the Hamptons. There are a few things that brings it back down to earth. To start with, the color. I mean, okay, I totally get that you wanted something different, but this pearl greenish off-white 70s shag carpet, I don't know, a clam threw up a pearl after eating spinach. I mean, what about white or even gray or orange? I mean, seriously, who the hell at Celestron in marketing picked this color? Next, you do not get a lot for the list price. You have to purchase the top dovetail if you want to mount anything on the top, as it only comes standard with the one on the bottom. It comes with a standard focuser, not even a 10-to-1 feather touch focuser like the 11-inch. Though on this particular point, they do have the new Celestron autofocuser, which I will be doing a video on here very shortly. But still, I mean, come on, at least give us a 10-to-1 focuser. I went and bought the light pollution filter for this, and the directions are easy enough on how to remove the existing glass filter, but that dang thing was damn near welded on. It took a lot of force to remove that filter, so much in fact that I wound up scratching some paint. Not the glass, thank God, but there's a little paint gone. The directions say to use fingers to gently remove. Yeah, not so much. In fact, my buddy Chris had the exact same problem. He had to buy a special tool for cameras just to get his filter off. If this is going to be a problem, Celestron, how about including a $1.50 tool to get those filters out and make it easier on the populace? Or at least leave them a little loose when they leave the factory. Telling your customers to go buy a spanner wrench, as they did in Chris's case? No. Finally, you know, if you're buying something for $1,700 and it comes with a battery holder and a case, why not we step it up a tad here, people? I mean, seriously, this thing looks like it came out from underneath a $30 Walmart RC car. And the carrying case? Yeah, it's like an oversized handbag for Barbie. Sorry, Barbie, yours is a lot nicer than this one. Okay, those things aside, I do believe Celestron makes good scopes. I really did love my SCT despite its shortcomings, and I'm super excited to get back to f2 imaging, especially with the dedicated astrograph. Yes! Being f2, you can shoot 30 seconds and achieve the same thing if you shot 3 or 5 minutes at f5. Instead of 100 3-minute shots, you might only have to do 50 at 60 seconds. Now, is that exact math? No, but it is close, and it's based on my experience I've had with my SCT and the Hyperstar. Now, this doesn't mean you cannot go 5 or 10 minutes or longer. You can. You can on really dim targets if you want. What it does mean is that you will get better results in less time in the field. You get wide flat fields, large aperture, huge light gathering abilities, and sharp images. I honestly cannot wait to get this thing outside and start experimenting with it. Hopefully in some future videos you'll see exactly what this thing can do. But you know the rules just as I. You get something new for astronomy, you get 3 weeks of rain and clouds. Therefore, I apologize to my brethren here in Georgia. I'm very sorry. Until next time, clear skies.